Hi, my name is SRIVASTAVA. I'm pursuing integrated analytics software engineering from VIT, and today we'll study about construction management. So, construction management, it has a subtopic called measuring software, and we need to measure software in order to realize the pros and cons of it. And like For measuring software, we have three things: product, process, people. These are the three metrics used to measure the software. Now, first we have the product metrics. Product refers to the actual software system, documentation, and other deliverables. We examine the product and measure a number of aspects. A product can have various aspects, like first aspect is size, like the size of the product, whether it is large or small. Second is the functionality offered. Functionality offered refers to like what all actions you can perform with the software. The third is the cost. Cost means whether the software is too much costly or whether it is has an optimum cost so that a normal person can afford it. And fourth is the various quality attributes for example, you can say performance or efficiency. So these are all the various quality attributes. Now second, we have measuring the process. Why we need to measure the process? We need to measure the process because it involves the analysis of the way a product is developed. By measuring the process, we can see whether the process is efficient or not. And second, what life cycle do we use? We know that for constructing a software, we use the SDLC, software development life cycle model. Now, third, what deliverables are produced? It means like when the software is developed, what all the products, what all the things that produce that can be used. Now, measuring the people. It involves analysis of the people developing a product. How fast do they work? It means if a group of people, if they are working fast, then our construction time will be less, and if they are working slow, then the software will take a large amount of time to develop. Now the third point is how much bugs do you produce. Like if the people that are working on the software, if they produce many bugs, then during the testing phase, we have to recognize all those bugs and fix it. So it will take a very large amount of time to implement the software. Now, how many sick days do they take? It basically means that how many leaves they will take. So that will also affect the making of the software. Now, the first part, product metrics. Examples of metrics, like this is basically an example of product metrics. Now we have a well-known company, IBM. Now IBM have a software requirement council. It has a set of metrics called the 5 and are defined and deal with first customer satisfaction. They focus on the customer satisfaction, like whether the customer is satisfied with the product or not. Second is post-release defect rates, like after the release of the product, how much number of defects it contains. Third, customer problem calls, like the number of problems or the number of times a customer calls them to tell that they had encountered a problem. Fourth is the fixed response time. It is the amount of time that the company IBM it takes to fix a particular bug after the customer reports it. And the fifth, number of defect fixes. It refers like the number of defects they have fixed in a particular amount of time. Okay. Now, what can we measure about a product? Like product has the various aspects as I told above. First is the size, and second we have the defect based metrics. Third we have the cost metrics. Fourth we have the time metrics, and fifth we have the quality attribute metrics. First is the size metrics. Knowing the size of a system is very important for comparing two systems together. Like because if we will not know the size, then we cannot say that which this is, for example, this is a system 1 and this is a system 2. So we cannot tell whether which one this is efficient or this is efficient. Software measurement in lines of code, LOC. Software is measured in lines of code, And big systems like large softwares in today's real world, they are measured in KLOC, 1,000 lines of code. Now, this LOC lines of code, it has a problem. Like, for example, I will assume this system is developed in C++. I will assume this system is developed in Java and this system is developed in Python. Now, Python and Java, C++. C++ takes 2000 lines of code for developing this system. Java takes 5000 lines of code and Python takes 15,000 lines of code. So we'll see that using different programming languages, but developing the same software, there is a significant difference between the lines of code. So this is the first problem with the LOC, lines of code. Now the second problem is same system developed by different developers using the same language will give different LOC ratings. As we know, like there are different developers who all have a different thought process. Okay, like I will think in a different way, and another developer he will think in a different way. So if even if we both are using same programming languages, then also I may develop a software which have 10,000 lines of code, and he may develop a software which have 5,000 lines of code, and we both may have the same functionality. So this is the another problem with LOC. And the third problem, to calculate LOC, you have to wait until the system is implemented. Now, for calculating, obviously, it is obvious that until you will not complete the software, you cannot count the lines of code. So you have to wait until the system is completed. And this is not adequate when managing, so requires prediction, cost, and effort. So this is the problem with LOC. Now, the solution to this problem is the function point matrix. Function point matrix provides a standardized method for measuring the various functions of a software application. Basically what function point matrix does is it measures the functions that the software has produced. It measures the functionality from the user's point of view. That what all functions I can access from the software, it will measure that, and on the basis of what user requests and receives in return, like what I will request and what I'll get in return. Now the third matrix is the defect density. Defect density metrics are rate metrics which describes how many defects occur for each size functionality unit of a system. It is basically like the number of defects upon the number of lines of code. It can be in KLOC or it can be in LOC depending upon the size of the software. Like for example, if the defect density is large, it means that we have for a given amount of size, then it means that the system is producing large number of defects, so it is not beneficial. And if the defect density is low, it means that we are having good software which is having the least amount of defects in the given system size. Now this is the second part, which is the process metrics. Why measure the process? Why we need to measure the process? If we can improve the process, we indirectly improve the product. The more and more efficient the process becomes, the product will also become efficient with that. Through measurement, we can understand, control, and improve the process. If we are able to measure the process, like what all good things and what all bad things are there, then we can improve the bad things and we can improve the measurement, we can improve the process. This will lead us engineering quality into process rather than simply taking product quality measurements when the product is done. Now we'll look at various process metrics. This is the first one, lead time. What we mean by lead time? Lead time measures the time taken from initiating a new process, such as starting work on a task, to its completion. It basically means that it is the amount of time taken when we start a process and when we finish the process. The time taken between these 2 points is called the lead time. It indicates how quickly work moves through the development process. By taking the help of this metrics, we can track how quickly the work is done or how quickly the development process of the software is completed. The second metric is the cycle time. Cycle time tracks the duration it takes to complete one full cycle of a process from beginning to end. For example, if we are developing a particular module of a software, and then for that we need to complete a process. From the beginning of the process to the ending of the process, the time taken is called the cycle time. It provides insights into the efficiency and effectiveness of the development workflow. This matrix, it is used to measure the efficiency and effectiveness. Now, the third matrix is the throughput. Throughput basically quantifies the rate at which tasks or features are completed within a given time frame. For example, I have to complete 10 features and I have to implement 10 features in 2 days. So this will be my throughput. And if I will do the 20, I will implement the 20 features in the same 2 days, then my throughput will increase. So it reflects the productivity and capacity of the development team. Like if I have a good development team, then they can implement a very large features in a small amount of time, and vice versa. If I have a like the development team is not that good, then they will develop like less features in the same amount of time. So throughput, this is an important matrix. It is used to measure the productivity. Fourth is the work in progress. Work in progress indicates the number of tasks or features currently being worked on but not yet completed. Basically, what it means that the number of features that the development team is currently working on. For example, it is working on 10 features, and the 10 of all of the 10 they are not complete, but they are under development. So this is called the work in progress matrix. It helps in identifying bottlenecks and managing workflow to ensure tasks are completed efficiently. Now, how can it manage workflow? Using this matrix, you will get to know that your development team is currently working on 10 features right now. So you do not have to burden them with more features. Now, the fifth is the defect density. Defect density measures the number of defects or bugs found per unit of work or code. As I said above, it is the same thing, like the number of bugs or the number of defects we get upon the lines of code. It helps in the assessing the quality and the reliability of software. Like if the LOs, if the defect density is less per the lines of code, then we have a good software. Else, the software is not that good, and we need to test it rigorously to find all the bugs and fix it. Now, the third is the people metrics. Why we need to measure the people? Financial purpose. For example, putting Joe on a project will cost me 500 per function point. And the second part, project management purposes. Michael needs to produce 5 function points per day in order to be timed. Like we can measure how many functions a person is producing, so that we can evaluate whether the project is on time or not. Third is the HR problem identification. On average, developers produce 5 defects per hour. James produces 10. It basically means that James is not that efficient, and he is producing more bugs than usual. Some of the people metrics are these metrics can apply to the developers or teams or individuals. First is the cost per function point, like the cost the cost we have per the function. Second, the mean time required to develop a function point. It means the average time we have required to develop a function. Third, the defects produced per hour, like 10 defects produced per hour, 20 defects produced per hour, like that. What defect produced per function point? Like for a given feature is implemented or a given function is implemented, how many defects do we have in that? 100, 10, 0, like that. Now, these are some of the useful measurements. We can assess the quality of the software. Size, total lines of code written, total comment lines, total number of classes or routines, total data declaration, total blank lines. Second part, defect tracking. Severity of each defect, whether the defect is like it will cause the your software to crash, or it will not it will not allow the software to function in a correct way. Location of each defect, whether the defect is located in a class, or whether it is located in a routine, or whether it is located in a main function. Where is that defect located? Third, origin of each defect. Requirements, design, construction, test. That which from where the defect arises, like it is a requirement defect, or it is a design defect, or is a construction defect, or during testing phase any defect has happened. So it means this, the way in which each defect is corrected. Now, how can we correct the defect? Like by testing, and when we'll test, then we'll get to know that where the defect is, and then we'll correct it. Person responsible for each defect, like which person, the person who caused this defect. Number of lines affected by each defect correction. If I will correct a defect, then in my code, in my software, how much lines are being affected? Work hours spent correcting each defect. This is the extra hours that I need to spend for correcting the defect, and it will not benefit me in any way. Average time required to find a defect. This is the average time required to find a defect, like it is 2 hours, 3 hours, and the low it is, the good for the software. Average time required to fix a defect. The average, it is the average amount of time that is required to fix a defect, and the low it is best for the software. Number of attempts made to correct each defect. It is the number of attempts, like the defect is being corrected in first attempt, or it is taking 2 attempts, or it is taking 3 attempts. Number of new errors resulting in defect correction. If one defect is corrected, then another defect can also arise from it. So it measures basically the number that are arised from correcting this defect. So that's all. Thank you.